Surprisingly, this is a fairly simple geometry problem that appeared on Indian National Mathematics Olympiad 2017. This is the first problem on the test, and let us go through the problem and try to understand what is given in the question. In the given figure, ABCD is a square. So we have a square A, B, C, D. It is folded along EF. So EF is the line along which the square is folded, such that D goes to D dash and A goes to A dash. And the line A dash D dash meets CD in G. And this is F and this is E. So this is the information given in the question. So we have to prove the end radius of triangle GCA. The end radius of this triangle is equals to the end radius of triangle A dash EB and FD dash G. So we have to prove that. Let us say the end radius of triangle GCA dash is equals to R1. End radius of triangle A dash BE is equals to R2. End radius of triangle GD dash F is R3. Then we have to prove R1 is equals to R2 plus R3. At this point, the question might look difficult to solve, and because of the terminology used in the question and lot of information that is provided, but it is a pretty simple problem with little bit of angle chasing and a minute algebraic manipulation. This is too easy a problem for it to be on the test like INMO. So this can be solved by a high schooler with a good grasp of basic concepts of geometry. So at this point, I would strongly recommend pausing the video and giving it a try. So let us dive into the solution. So let us analyze the construction that we have made first. So this angle, since this angle is 90 degrees, this angle is also 90 degrees. And since this angle is 90 degrees, this angle is also 90 degrees. And this is 90 degrees because it is a square. For the same reason, this is 90 degrees. Now, let this angle be theta. Then this is 90 minus theta. And this will be theta. This is 90 minus theta. This is also 90 minus theta. This is theta. If we see triangles EBA dash and triangle A dash CG and triangle FD dash G, these three triangles are similar, and the angles of the three triangles are theta, 90 minus theta, and 90 degrees. So these three triangles are similar. So let us say EB is A dash B is B, and A dash E is C. So then, since these triangle A dash BE and triangle A dash CG are similar, so the angle opposite to theta in this triangle A dash BE is B. So the angle opposite to theta in this triangle B, let's say BK. So GC is BK, and let this be AK, let this be CK. Similarly, the angle opposite to theta in the triangle FD dash G be BT, and this is CT, and this is AT, and FG is CT. Since FD dash is AT, FD is also AT. For the same reason, since A dash E is C, AE is also C. Okay. Before solving the problem further, so I'll quote a relationship between in radius of a triangle, circumradius, and the angles of the triangle. So the in radius of triangle is equals to 4 times r times sine A by 2, sine B by 2, sine C by 2. So now if we consider these three triangles A dash BE, A dash CG, FD dash G, the angles in all the three triangles have the same angles. So this factor will be same for all the triangles. So proving R1 is equals to R2 plus R3 is as good as proving small r1 is equals to small r2 plus small r3. So we will go ahead and prove this. Since all the triangles here under consideration are right angle triangles, the circumradius will be half of hypotenuse. So R1 will be A dash G by 2 is equals to R2 will be A dash E by 2 plus R3 is FG by 2. So A dash G is equals to A dash E plus FG. A dash G is CK is equals to C plus FG So K is equals to T plus 1. So proving that K is equals to T plus 1 is as good as proving R1 is equals to R2 plus R3. So we will go ahead and prove that K is T plus 1. Since this is a square, AB is equals to BC is equals to CD. And this is also is equals to A dash D dash, because before folding A dash D dash was AD. So the length will not change. So now AB is A plus C is equals to BC, B plus AK is equals to CD, BK plus CT plus AT is equals to CK plus BT. Now consider these two. So we will get K is equals to A plus C minus B upon A. If we consider these two, C plus A minus B times of D is equals to C minus B times of K. So T is equals to C minus B by C plus A minus B into K. We already found out A plus C minus B upon A. And this will be cancelled. So T is equals to C minus B by A. So now here K is equals to 1 plus C minus B by A. But C minus B by A is T. So K is equals to 1 plus T. So we have proved this. K is equal to 1 plus T. So that is as good as proving this. Small r1 is equals to small r2 plus small r3. Yeah.